Mastering these different phases is very important for you, not only for your CCNA wireless exam, but also for your life as an admin, because many people get confused between these phases. They think that one happens and then the process stops and the next one happens. So you need to understand their order. The first thing you need to understand is that the access point is going to try the discovery phase. And that discovery phase is to try to find as many controllers as it can. And it's not because it discovers one that it's going to stop there. It's going to apply all these methods we're going to see together until it has done them all. And then at the end of it, it's going to see how many controllers it could discover. Once this list is done, it's going to choose one of them. And that's what the join phase is about. It's going to pick up the best one and we'll see how it decides of that. And it's going to join that controller. Once this join phase passes and the exchange is complete, then the AP will enter the discovery phase. And that discovery phase is about getting a refresher from the controller about what configuration the AP should have. So those three phases are one after the other, but they are independent. You need to finish one before moving to the next one. So let's first look at the discovery phase. If you think about it, and if you are an access point and you boot, how do you know where to find a controller? You know you need one because you're a CAPWAP access point. If you're autonomous, then you can just behave by yourself. But if you're a CAPWAP access point, you cannot do anything until you have a controller that tells you what your configuration is going to be. So your first and only job in life as a CAPWAP AP is to discover a controller, join it, so that you can know how to service client. So because it's a complex phase, we have many ways for the access points to discover the controller. And the AP again is going to try them all until it has a complete list of possible controllers to go to. The first way the access point has is simply to try its own subnet. The AP by default uses DHCP, so when it boots, it's going to get power from a power brick or from PoE, and then as soon as it has completed its boot sequence, it's going to try to get an IP address via DHCP. And then it's going to send a discovery message in that subnet using a broadcast address. So if your AP has a 10.10.10.something address /24, it's going to send to 10.10.10.255, what we call a CAPWAP discovery message. This is a message sent, you remember CAPWAP control, to port UDP 5246. And that message is simply a discovery request saying, is there any controller in this subnet? If there is a controller in the subnet, or if there are controllers in the subnet, they are going to respond, unicasting back to the access point saying, yes, I'm WLC XYZ, I am available. So this will allow the access point to set up maybe a first list of possible controllers it can go to. Again, maybe the AP will discover 3 like in this example. Maybe it will not find any controller there, but at least it will try this first method, a broadcast discovery in its own subnet. The other method that the AP is going to use is something which makes a lot of noise in the industry because typically people are not sure they understand how that one works. This is what we call the DHCP option 43. Okay, so what is that? Well, in the DHCP protocol, which is not Cisco, right? There is a protocol called DHCP. There are a certain number of options, many of them. One of them is DNS server IP address, one of them is gateway, etc. And one of the options is called 43, and it's named vendor-specific option. What that one is to say, if you are a vendor and your device is going to get a DHCP assigned IP address, maybe you need to send to that device a specific information which is vendor-specific, meaning that only that device belonging to that vendor is going to understand what that information means. Well, if you need to do that, there is an option in DHCP where you can do that. And this is what we can do here as well. So if you set up your DHCP server, you can configure it to return to that access point, an access point option that only the APs understand, and that information is controller IP address. It's vendor specific because you understand a laptop will not understand what controller IP address is supposed to mean. You have to be an access point to make sense of that information. As a matter of fact, and the reason why this is sometimes confusing is because the option for the AP is actually 241. From all the options that the AP understands, controller is 241. So the field that is going to be returned back to the access point will say 241 for you is that IP address. 241 is like the police code, when we say 10-4, etc. So for the AP, 241 means that what you're sending to me is the controller management IP address. Got it. So what is the IP address? And we see that. So from the DHCP server standpoint, this is option 43 because it's a vendor-specific option. From the access point standpoint, this is option 241, which means controller management IP address. All right, so that's the option 43, meaning the DHCP can return that information to the access point, and if the AP has that information, it's going to get the IP address of one controller, maybe more than one, and it's going to send a unicast discovery message to that IP address or to each of those IP addresses if you return many. Thing is, the format of this address is a little bit specific. If you are on a Windows server, it's going to be an IP address as you know it. But if you are on an iOS DHCP server, it has this weird format. And that is a format that you probably won't be tested extensively on, but if you want to configure a network and if you use an iOS DHCP server, you need to understand how that works. So let's have a look together. The structure is this way. You have F1, 04, and some numbers. The key here is to understand that F1 means that what you're returning is in fact an hexadecimal value. So in the iOS, it's always going to start with F1 as an option, and that's a way to know that we are returning an hexadecimal number behind. So it's always, when you configure on the iOS, starting with F1. Then the next two numbers is going to be something like 04 or something else. And what 04 means, it's the number of bytes that you're going to return. And here we think in IPv4 logic, right? So an IPv4 address is 4 bytes. So when I say F104, I'm saying I'm going to return an hexadecimal version of an IP address that has 4 bytes. So that's, of course, if you return only one controller IP address. If you return 2, for example, well, you would say 08 because you're returning 4 bytes for one and 4 bytes for the others, so that's 8 bytes. What about if you return 3? Well, it's not going to be 12, right? Because this is hexadecimal. So when you go to 10, in fact, 10 in hexadecimal is 0A. So you go 08, 09, 0A, 0B, 0C. So 12 bytes, in fact, is going to be said 0C. Looks confusing? Well, keep in mind, it's just hexadecimal. But in most cases, you're not going to return 3 IP addresses. The most common case is 1, sometimes 2, and that's very uncommon. But, keep that logic. Those numbers are hexadecimal. Then the rest is simply the IP address in hexadecimal format. 0A, 0F, 64FD. Each of them is 1 byte of the IP address expressed in hexadecimal. So if you translate it, 0A is 10, 0F is 15, 64 is 100, and FD is 253. So what you're saying here is that I'm returning in hexadecimal format F1. 4 bytes, and this 4 bytes is 10.15.100.253. That's the IP address of the controller you may want to try. You put that in the option 43, and this is returned to the access point along with its IP address. So the AP gets the IP address, gets that option and says, all right, let me try also on top of my broadcast discovery that I do anyway. Let me also try to send a discovery message unicasted to 10.15.100.253, see if there is still a controller there that's listening that I may be able to add to my list. If you return 2, it's the same logic, except you just put the 2 IP addresses one after the other. So if you were to return 2 IP addresses, it would look like this. You can put some dots between the bytes to make it look better, but it's the same logic. You just say F1 to say it's hexadecimal, 08 because you return 8 bytes, and then you just stick the 8 bytes, the first IP address and then the next one without separation. All right, so that's pretty simple. There's another additional option that you can add to option 43, and that's also something that makes it a little bit confusing. And that is what we call the option 60. The option 60 in DHCP language is the client identifier. So what that does is to say, well, if you just implement option 43, any device in the right subnet asking for an IP address is going to get an IP address, of course, and the DHCP server is going to return all the options. The DNS, maybe the gateway, and the option 43. Because the DHCP server doesn't know if you are Cisco or something else, so it does not know if you need that option 43 or not, so it's going to return it anyway. Except if you also implement option 60 in that DHCP server, by which you say, wait, I'm expecting from the access point client to identify itself as being AP 3700, for example. So any client that identifies itself as being a Cisco AP 3700, to that guy, you're going to return the option 43. But if the client doesn't identify itself as being AP Cisco 3700, you don't return the option 43. That is what the option 60 is about, making sure that we can filter the client's identifier first before deciding to return the option 43. Does that look complicated? It may, and actually, you may not need to spend too much time on that. Why? Well, two things. First of all, in a normal design of your network, you're never going to mix the client subnet and the infrastructure subnet. So if your APs are in a subnet where they query IP addresses, there shouldn't be any client in that subnet, otherwise your design is wrong. So there is not a need really in most networks to filter who is going to ask, because if that device is in that subnet, it is, by definition, an infrastructure device. So that filter may not be necessary. Also, that filter works on an identifier. So if you have only 3700 access points in your network, that's fine. But if you have a mix and match between 2700 and 3700, what option 60 should you set? Because you have to define what is the call, what is the identifier. So that option 60 is a bit restrictive because it limits you to one single model of access point. So in most networks, you might hear about option 43 and option 60, but in fact, option 60 is practically not implemented anymore. But for your awareness, these two may be working together. So at this point, you've done a broadcast in your subnet, you may have found some controllers. Then you will return IP addresses via option 43 maybe, and you try to unicast a CAPWAP discovery message to those addresses. And maybe you got responses from these controllers. So your list of controllers is pretty nice already. But that's not enough. There is another way, which is DNS option. And what that is that if in your DHCP options that you got from the DHCP server, one of the options was the IP address of a DNS server, you now have DNS information. And what the access point is going to do is contact that DNS server and say, Mr. DNS, do you know any host which name would be cisco-capwap-controller whatever domain you're in, cisco.com, whatever. And if you configure your DNS accordingly, you could have set up an entry there to say, well, I can give also an IP address to that host Cisco CAPWAP controller, which makes that if any access point needs that IP address, it's going to query the DNS server, and I will send back that IP address. That will give the AP one more IP address to try. This is how it will look like on the Windows server. This is a DNS server in Windows, and you see I just create an entry called Cisco CAPWAP controller in my domain here, which is ccnalab.com, and then I give the IP address of that controller to that host entry. So any access point querying this DNS server, which it would have learned from the DHCP options, is going to ask for that name, Cisco CAPWAP controller, and I will send back 10.10.10. So at this point, the AP has three options: broadcast, option 43 with DHCP, if it has the possibility DNS, and there is another way, the fourth way, which is that the access point, if it has been before connected to a controller, it will remember. And actually it will remember up to 8 controllers it may have been connected to before. So that's a kind of a memory of previous lives, if you think so. So from that configuration, the AP is also going to use those IP addresses and try to unicast a discovery message, CAPWAP discovery message, to those IP addresses it remembers from its previous lives. Of course, if the AP is out of the box, factory defaulted, it doesn't have that. But if you plug the AP before and if you join the controller before, it will also try to come back to that controller. This may be interesting in some cases where you don't have a broadcast success, you don't have a DNS information, you don't have option 43 in the DHCP, and you see the AP still trying to contact a controller. That's a very strong survival mechanism. In some cases it may be surprising, but that's a way for the AP to keep on growing that list so it has as much controllers as it can before it decides which one to choose. You can also configure the AP, by the way, once it's in a controller, to choose one controller. So that also participates in that memory. All right, so now my AP has tried all these methods, and keep in mind it's not because it has discovered some controllers using, broadcast, that it stops there. And it's not because you configure the DHCP option 43 that it stops there. It's going to try all these methods, one after the other, until it has a list of controllers it can use. So it doesn't stop, it uses all the discovery methods to build the list, and that's the first phase.